Welcome to all my dear student. This class will see about from the continuation of acid bases and buffers. So from that what are the sub topic of measurement of tonicity. So what is the definition for tonicity? It's nothing but the ability of an extracellular solution to enable water to migrate into or out of a cell via osmosis is referred to as tonicity, or otherwise we may say it is a property of a solution in reference to a particular membrane and is equal to the sum of the concentration of the solute which have the capacity to exert an osmotic force across the membrane. That is very important. Which have the capacity to exert an osmotic force across the membrane, or the solution to enable water to migrate into or out of a cell via osmosis is referred to as tonicity. So tonicity also depends on solute permeability. It's nothing but permanent solute do not affect tonicity. Impermanent solutes do affect tonicity. So what are all the methods used for the measurement of tonicity? There are the two methods. First one known as cryoscopic method and second one known as hemolytic method. We'll see one by one. So what is the two methods, cryoscopic and hemolytic? Cryoscopic and hemolytic method. We'll see first. So many drugs and chemicals are used in pharmaceutical formulation. So these substances contribute to the tonicity of the solution. So hence the methods are needed to verify the tonicity and adjust the isotonicity. So we already discussed about what is the concentration of isotonic solution. It's nothing but 0.9% sodium chloride solution. So these are the two methods. So usually that many drugs and chemicals are used in pharmaceutical formulation as to adjust with the isotonicity. So these are the two methods to determine. So by using this method we can adjust the tonicity in that isotonic solution. So first one, cryoscopic method. So by this method the isotonicity value can be determined from the colligative properties of the solution. By using this method we can able to determine the isotonicity value of the pharmaceutical drug or substances. So for this purpose, freezing point depression, it is denoted as delta TF. So what is a freezing point depression? It is denoted as delta TF. Property is most extensively used. So the freezing point of water is 0 degree Celsius. Suppose if we add any substance such as sodium chloride is added to it, so what will happen? So the freezing point of water decreases. So the freezing point of depression of blood is 0.52 degrees Celsius. So hence the freezing point depression value of drug solution must be minus 0.5 degrees Celsius. So the solution shows on osmotic pressure equal to that blood. So what is that freezing point of depression of blood is 0.52 degrees Celsius. So we have to adjust the tonicity to, or it brought to the drug solution, or it must be 0.5, drug solution must be 0.52 degrees Celsius, so that we can achieve the osmotic pressure, or we can, it is equal to that of that osmotic pressure equal to that blood. Okay, so this is the cryoscopic method, how can we adjust the value? So we have to adjust to the depression of blood, freezing point depression of blood, or we have to brought to that equivalent to that freezing point of depression, so that it is very easy to adjust with that tonicity of drug solution. So next, what about next method, hemolytic method? So hemolytic method is nothing but it's a quantitative method developed by a hunter for the measurement of tonicity. So there in cryoscopic method we can find out the isotonic tonicity value. Here we can determine by quantitatively. So under this method, effect of various solution of the drug is observed on the appearance of red blood suspended in the solution. So by using this method we can find out the effect of various substances, various solution, so that solution to be suspended in that RBC red blood cells, so that we can observe that whether the RBC cell is getting wrinkled or shrinkage or bursting or swelling of that RBC by using this quantitative method. So in hypotonic we already discussed in that buffers in isotonic solution. So depends upon the solution, whether in case of hypertonic solution there we will use 2% of sodium chloride solution, thereby that the cell will cause wrinkled or shrinkage. Suppose if in case of hypotonic solution, that is 0.2% of sodium chloride, means the cell become swelling, and sometimes the cells burst also will occur. So but in case of isotonic solution there is no changes occurs on the cells, so it retains the same size and shape. Okay, here how can we determine quantitative? Means in hypotonic solution the oxyhemoglobin released is proportional to the number of cells hemolyzed. So it is mainly depends upon them. Now in hypotonic solution means we will use 0.2% of sodium chloride solution. So the oxyhemoglobin released is proportional to the number of cell hemolyzed. Lysis is nothing but breaking of the RBC. So in case of hypertonic solution the cell shrink and become wrinkled. So whereas in case of isotonic solution the cell do not change their morphology is nothing but study of their morphological character, that means size, shape and all. Okay, I think you will get very clear idea about the measurement of tonicity. By using with these two methods we can find out the tonicity, or by using with this method we can adjust the tonicity of the pharmaceutical drug substances. Thank you.